Mm. In this lab, we will continue with the causal analysis. So, what we were doing was we were we were doing causal inference using propensity score matching. Propensity score matching is a widely used technique in causal inference. It aims to estimate the causal effect of a treatment or intervention on an outcome variable in observational studies. The core idea behind propensity score matching is to balance the covariates between treated and control groups, making them more appropriate. So in step 1, we surveyed the data that have already been collected. Often our covariates are potential confounders that could bias our results. The intervention equal binary yes or no, and follow up on our outcome equal binary yes or no. In We adapted the code to define covariates so that we only take numeric variables. Then we re-implemented the logistic regression model. In step 2, we calculated propensity scores. The propensity score is the probability of receiving the treatment given the covariates. We performed a classification model to estimate the probability for a person to belong to one of the two classes. Experienced crime has a victim where experienced crime equal 1, has not experienced crime before where experienced crime equals 0. Hence, for this model, the target variable should be the treatment variable experienced crime. And we adapted the code to define covariates so that we only take numeric variables, then re-implemented the logistic regression model. In step 3, we matched the treated and control units. The idea to match a Mrs. X who hasn't experienced crime has a victim before to a Miss Y who has. There are various matching techniques, example nearest neighbor, exact matching, we can use for propensity score matching. Here, we'll use nearest neighbor matching as this is the most flexible yet powerful method. In this lab, we will assess the balance. Now with the propensity score matched, we can use visualization and descriptive analysis to show that the treatment and the control group have been similar. To visualize the quality of the matching, we compare the distribution of propensity scores between the treated and control groups before and after matching. We import matplotlib.pyplot as PLT. And we also need to import seaborn is SNS. So now we plot the original data. PLT.figure, fig size equal 12, 6. SNS.kde plot of treated of column propensity score, label equal treated. SNS.kde plot of control data frame, but propensity score from there, label equal control. PLT.title of distribution of propensity scores, that is original data. PLT.x label propensity scores. PLT.y label frequency. PLT.legend location equal lock equal upper right. PLT.show opening close bracket. So we see that the treated density plot and the control density plot. So the propensity scores for less than 0.1, the density gets higher for treated and control. But for more than 0.1, the density, the frequency of the density for treated and control gets starts decreasing. When we plot the histogram, we see that the control group and the treated group we see in terms of bins. The control groups, the frequency is much higher than the treated group. And the treated group are the ones where experience crime equal 1, and the control group is where the experience crime equals 0. Then we plot propensity scores for matched, treated, and control samples. SNS.kde plot of treated matched data frame of propensity scores, label equal treated. SNS.kde plot of control mesh data frame of propensity score column, label equal control. PLT.x label propensity score, PLT.y label frequency, PLT.legend lock equal upper right, PLT.title distribution of propensity scores, PLT.show opening close bracket. So it shows that the density of the propensity scores for both treated and control groups are same. They are right on top of each other. Now when we plot the histogram, PLT.hist of treated matched propensity score, alpha equal 0.5, label equal treated, bins equal 30, color equal blue. PLT.hist of control meshed of propensity score, alpha equal 0.5, label equal control, bins equal 10, bins equal 30, color equal red. PLT.x label of propensity score, PLT.y label of frequency, PLT.legend of log equal upper right. So the legend is put on the location upper right. PLT.title of distribution of propensity scores, PLT.show opening close bracket. Now we see the histogram is almost on top of each other. The treated group shows a bit higher bars. Along with the propensity score comparison, if we look at the descriptive statistics between the treated and control group, we can clearly see the similarity too. Let column to compare equal age, education, employment, income bracket. For call in column to compare, let's print the treated of call dot unique open and close bracket and new line control of call dot unique open and close bracket. So that will print for each of these columns, it will print the unique values. They are quite similar. Calculate descriptive statistics for treated groups. Let treated stats equal treated of column to compare. Column to compare is the array of the four columns. Dot describe open and close bracket. And it gives this. Calculate descriptive statistics for control groups. Let control stats equal control of compare to column to compare array dot describe open and close bracket. So we get this. Combine the statistics into a single data frame for comparison. Let stats comparison equal pandas dot concat curved bracket and then the square bracket treated stats comma control stats comma x is equal 1 comma keys equal treated and control. Display the comparison, so stats comparison. So the keys are printed, treated and control, and for treated we have this descriptive statistics, and for control we have this descriptive statistics. By putting x is equal 1, we are comparing them side by side. So we can see that the count of age, education, employment, income bracket is 25,066, and for control group it's 95,614. That's the number of the data rows in treated data frame and control data frame. The mean for treated data frame for age is 37, while control group mean is bit higher, which is 43. Education, for education the control group shows bit higher mean as well, and for employment the mean is bit higher for the control group, and the income bracket the control group mean is bit less. The standard deviation is bit higher for age, education, employment, but for income bracket it's bit less. The minimum is 15 for age, 1 for education, employment is 1, income bracket is 0.2, and it's the same for control group. The first quartile is 25 for treated for age column, but it's 28 for control in control data frame. For education, the 25% quartile is 1 in treated data frame, but it's 2 in control data frame. For employment, the 25% quartile is 1 in treated data frame, and is 1 in control data frame. The maximum. Let's look at maximum. The maximum is same for treated and control data frame. 99 for age, education is 3, employment is 6, income bracket is 1.